everybody, I'm Roman Rodriguez and we are doing physics chapter 6 equilibrium, and this is lesson 6 and we are on the 6th question. It says over here that a painter weighing 150 Newton, the weight of the painter acting downward is 150 Newton, is standing on a uniform plank of 10 meter long at a distance of 2 meters. So the distance from here to here is 2 meter from one end, okay? Of the plank. The weight of the plank is 50 Newton. The weight will act at the center, say 5 meters from here and 5 meters from here. So the weight of the plank over here would be 50 Newton. Okay, there you go. And it is supported by 2 ropes, okay, at the ends as shown in figure. Find the tension in the rope. You have to find what T1 and T2 is equal to, the tension on the rope. Right, so we'll apply the first condition of equilibrium where sum of all forces acting along x-axis is 0 and along y-axis is equal to 0. Now there are no forces acting along x-axis horizontally, all the forces are acting along y-axis. Like you can see over here, T1 plus T2 should balance the force that is acting downward. These are the upward force T1, T2. The downward force is the weight of this painter, which is 150 Newton, and the plank, which is 50 Newton. So 150 plus 50, that will give you T1 plus T2 equals to 200 Newton. Okay, we can bring everything on one side and we can say T1 plus T2 minus 200 equals to 0. So this is the first equation. There you go. Now, in order to find the second equation, we'll apply the second condition of equilibrium where the torque turning effect should be equal to 0. Sum of all turning effect. That is, turning effect, is force into displacement. And the force that you see over here is T1 and the weight which is acting downward. So let's say on the left hand side we have T1 times the displacement over here. The displacement from here to here would be 50 Newton to the center. So 5 meter from here to here is the displacement. T1 is force we do not know. So T1 times 5 would give you 5 T1. Plus on the left hand side again the person is over here, standing here, and the weight of the person is 150 Newton. And the distance from here to the center, you will see, since he's 2 meters away from the from this side to the rope. So to the center, if you look at it, the distance from here to here is 5 meters, so he is 3 meters away from the center. So his weight times 3. His weight is 150 Newton times 3. Okay, is equals to, now on the right hand side, we know the distance is 5 meter and the force is T2. So torque will be T2 times 5, which is 5 T2. Right, now we bring everything over here, so T5 T1 minus 5 T2 plus 150 times 3 would give you 450 equals to 0. So here we are, we've got the second equation as well. Now, let's solve these two equations simultaneously. We multiply this equation by 5, so we'll get 5 T1 plus 5 T2 minus 1000 is equals to 0. And the second equation will remain 5T1 minus 5T2 plus 450 equals to 0. This is 1000. So I did this so that I could get rid of this T2 to cancel out. So 5 plus 5 would give you 10 T1 minus 450, 1000 minus 450 will give you 550. 550 equals to 0. Let's move this over here. So 10 T1 is equals to 550, or T1 is equals to 550 divided by 10. So the tension would be 55 Newton on the rope which is along left hand side. We just calculated T1, which is 55 Newton. Now we substitute the value of T1 in any one of these equations. Let's say in the first equation, which was the original equation, was T1 plus T2 minus 200 equals to 0. So T1 is 55 plus T2 minus 200 equals to 0. So let's move 200 on the other side. So I'll get 55 minus 200 is equals to what? 200 minus 55 would give you Oh, how much it is? Let's move it over here. See, T2 is equals to 200 minus 55. And that will give you T2 is equals to 200 minus 55, 5, 10, 5, 6, 7, 8, 9, 10, 4, 145? 5, 6, 7, 4, 10, yes, 145. So the tension along the other side, this side, would be 145 Newton. Okay? So this is the answer. We have just worked it out. T1 is T 55 Newton and T2 will give you 145. I hope it's clear to you all. And we'll be solving the last question of this chapter in the next lesson. Till then, take care.